Hey everyone, continuing on with Chapter 2, we've made it to Section 2.2. So this section is just more on additional types of graphs and displays. So let's jump right in. The first thing is what's called a stem and leaf plot. It's a way to organize a raw list of numbers in a data set. The advantage is all of the data set values are preserved, so you still have them. However, the disadvantage is it's not so good for larger data sets. So I would use this technique for maybe this size or smaller. But the way it works is you have a stem and a leaf. So you usually start with a little vertical line, and on the left-hand side, we'll put the tens place. And so we know all of the numbers start with 5, 6, 7, 8, or 9. So I'll just do those vertically. 5, 6, 7, 8, 9, knowing that all those represents tens, digits. And then in the ones place, we'll just accumulate the numbers in ascending order. So in other words, for the 50s, the lowest one is 50. So I'm just going to put a 0, right? And then cross out that number. And then there's a 51 over here, so I'll put a 1. There's a 53, and etc. Right? So, and then there's a 54, there's a 55, and a 59. And if I were taking my time doing this, I would cross them all out as we go. Right? So there's a way we organized the 50s. And then when I get to the 60s, there's a 62, a 65, a 66, and a 67. And notice I'm kind of keeping it lined up so I can compare how many there are in the 50s and the 60s, right? The 70s turns out to be something like this. Now notice here I'm putting 3 3s. That's because there are 3 73s, right? So if you have multiple numbers for the same value, like there's the 2 73s there, there's one more somewhere probably, there it is. So that represents those 3 numbers, right? So then it goes 74, 75, 75, 76, 77, and there are 4 78s. Okay, and so just finishing this off for the 80s, you would end up with this. So again, it's a bit tedious to generate this, but works out. Okay, and there's your stem and leaf plot. Also, along with a stem and leaf plot, it's always good to have a key, because just by looking at this, we don't really know that the left-hand column, the stem, are tens place, and these are ones. I mean, it could be like 5.0, 5.1, 5.3, right? We don't know. So on the side, usually you would have something like 5 line 0 is representing 50, right? Then we know, the reader will know what these values represent. So cool thing is you still have all the data values, and you still have the pattern, right? Like if you kind of turn your head to the side, it still has the feature of a histogram, right? If you think about these as bars, oops. So you still get that feature. Okay. But again, if you had like 1,000 data values, this would not be good, right? Unless you had some sort of computer program that could generate it. And even then, might not be the best way. Okay, here's one that's already been generated, and then we have a few questions to answer. So we have a key, right? So we know that the left is, or the right is ones places, right? The key is 10/4, 104. Okay. So what's the minimum data value, right? So our minimum data value will be the very first, the 1, 7, right? So that will be 17, right? The maximum data value, if we go all the way to the end, we got that 148. Okay. Now how about the range of the data values? Well, that would just be those two values subtracted, right? Range is max minus min, so that's 131. And then finally D, what is the number of data values between 40 and 70. Right? Now, careful here because there are, okay, so for the 40s, right here, there's 1, 2, 3, 4, 5, there's 7 of them there. There's 4 of them in the 50s. There's 3 of them in the 60s. But once we get to the 70s, that represents 73, 75, 75. Those are all larger than 70, so we would not include those. All right, so we would just add 7 plus 4 plus 3 only for a total of 14. Okay, so those are our answers for number 2. Moving on, just some other types of plots and graphs. Dot plot, kind of a nice way to organize data. Again, it's good if you have a reasonable amount of numbers, but here you just create a number line and you put dots above the values, right? So if we tried one out, here we have basically 0 through 8, so I would just draw a number line going from 0 to 8, and then for each number, I'm just going to stack dots above that number depending on how many we have, right? So there are 3 zeros, and again, use that technique of crossing them out as you go is helpful, right? I think there's like 6 ones. Right? We have 5 twos, a couple of 3s, a 5, and an 8. So there would be a, what's called a dot plot. Okay. Graphing, next types are graphing qualitative data. Qualitative data means non-numerical, basically, like you just have categories without numbers involved. Common one is a pie chart. Don't have to spend too much time on pie charts because those are really common, right? But just know that the sum of all percentages in any pie chart always has to be 100%. Right? If it's not, then it's a faulty graph. Make sure they're equaling 100. 2 most popular food choices obviously are pizza and hamburgers. That makes me hungry. It's around lunchtime. All right, but don't get too distracted. How many students in the study chose hamburgers? Okay, so usually a pie chart has percentages. You can always convert that to a number if you know the total number of people in the study, right? So hamburgers is 27%. So I just need to find 27% of 500, which is a multiplication problem. 0.27 times 500, 135 would be accurate. All right. All right, moving on, a Pareto chart. It's kind of like a histogram. However, it's for qualitative data. And one key feature of a Pareto chart is that the bars are always in descending order, tallest to smallest. And notice there's, again, categories at the bottom instead of a number line. Those are the 2 key features for a Pareto. Otherwise, they're pretty easy to read, right? Obviously, the leading cause of death in 2019, heart disease. It's the tallest bar. And then approximately how many deaths were caused by accidents. All right, so that's accidents there, right? So that's this bar. So just have, estimating, looking at the y-axis about, it looks like about 180, I would say, right? So I'd probably go approximately 180. We're approximating because we can't see it exactly. And then how about this one? Determine which Pareto chart accurately displays the data of middle counts. Okay, so it should be in descending order, which they all are, so that's good. And then which one is the most? Looks like country C had the most metals, so C should be going first, right? So the only one that has C first is B, so I will go with B on that one, right? And then just notice, the right order C, E, B, D, A is in descending order of how many metals the country received. All right, so there we go. That's Pareto chart. Moving along, we've got some graphs when you have paired data sets. Okay, so paired data sets when you have two variables for one subject. So a very common type is called a scatter plot. And here's an example of one, right? And scatter plots are a good way to notice any trends in the data. For example, here we have petal width versus petal length for irises. So we have length along the x-axis and width along the y. So important to note, each dot is a flower, right? And then it's giving two pieces of information for each flower subject. And we can notice some trends, right? So the question is, as the petal length increases, what tends to happen with the petal width? Well, I can kind of see an upward trend in these dots, right? So it seems like, in general, right, as the length increases, so does the width. Okay, so increase as well. So for scatter plots, you really are looking for general trends. Of course, it's not going to be a perfect trend, or else they'd all be on a straight line. But general trends is what we look for. We'll see more about scatter plots in Chapter 9. One more type is called a time series. A time series is basically, again, quantitative entries where we have time versus some sort of measurement. Right? So when you graph these out, you're always going to have time on your x-axis. Right? And in this case, we have years, right? 2011, 12. I'm not putting the 2000s. I'm just putting the last two numbers, right? Okay, and then this is a very rough sketch along the vertical axis. Again, I'll show my little I would have maybe a scale of, maybe start with 90, because I don't see anything less than 90. And let's go in increments of 30 units, something like that. And then I would just plot the data. All right, and I'm just going to kind of do a really rough job here. But it ends up being something along these lines, right? And then you can just connect the dots. This is a horrible graph. If we had technology, which we'll get to with StatCrunch, it'll look so much better. But just a general idea, right? And then, of course, we can see any kind of patterns. Describing the pattern, obviously, we see that as time increases, or as time goes along, the, what is this, number of degrees? Yeah, number of degrees increases over time. So degrees increase over time. Something like that. Okay. Finally, to finish this section off, how about misleading graphs? Those are kind of fun. Right? A misleading graph is a graph that is not drawn appropriately, and it does mislead the reader. They aren't necessarily incorrect. Oftentimes they're perfectly accurate, but they could be better. And here's an example. Right? So here we have two graphs. We're comparing average house prices in 2 years. Man, houses were cheap back in the 90s. Too bad I didn't buy a house back then. We're comparing 98 to 99. If you look at these two graphs, they actually have the same data. Right? The orange bars top out at 80. The yellow bars top out at 82. However, notice the difference. In the right-hand one over here, the y-axis is actually not starting at 0. Whereas on the left-hand one, the y-axis does start at 0. In the left-hand one, it looks like there's not a lot of difference between 98 and 99 as far as house prices go. However, in the right-hand one, it looks like there's a huge difference. Like, wow, look at that bar. It's like, this bar is like 3 times the size of this bar. Wow, housing prices skyrocketed in 99. Right? So this graph is misleading. Right? It's showing a big jump when there actually really was not a big jump at all. Right? So misleading. So you'll see this quite a bit where they'll try to start a graph that's not at 0. For it to be accurate and tell the real truth, it probably should start at 0 right there. Okay, so that one's cool. One more. How about this one? What's misleading about this graph? Let's say we're comparing barrels of oil between two types of countries. Well, I don't know. What do you think? I can't really ask. I just got to tell you. Really, this is a bar graph, right? The only thing that really matters as far as the data goes is the heights of the bars. Right? But notice what this one has is a larger width as well. So it's not only changing the height but changing the width too. That's misleading. It's making this one actually look a lot bigger than it really is, right? So the misleading thing is that the barrel width is wider, or the barrel is wider. And so, if you wanted to portray accurate data, you probably should keep the widths of the same, since it's not a factor. We're only comparing the heights as far as the numbers go over here with barrels in millions. Okay. Oh, look at that. We ended a section. So that's a good spot to start. Stop. So that's 2.2. Take a look in my lab, see what you think. If you have any questions, send them my way. I'll respond as soon as I can. Thanks for listening, and I'll talk to you next time in section 2.3.